Here we go. We're starting a new chapter, chapter 10. Let's take a look and see what 10.1 is about. It's about lines and segments that intersect circles. So, you may think right here, we're not going to see any more triangles, right? Well, you are wrong. We will still have triangles in this chapter. But at least you know a whole lot about triangles now. You know how to find angles and sides. Let's see what else we could learn about them. But let's go ahead and start right here. Let's take a look and see, well, what is a circle? Let's take a look at some vocabulary terms. Make sure you guys, with your vocabulary terms, please write them down, especially the ones that are already typed out. So if you're not using big ideas to go along with your student journal to help you along with the your notes, make sure you write them all out. So, official term or vocab for a circle. Okay, what does it mean? It is a set of all points that are equidistant from the center. Remember, a circle is nicely rounded, and in order for it to be round, it is equidistant from the center. Think about your compass, right? You have your compass, you got the needle, it goes to the center, you got the pencil on the other end, and then you go ahead and draw a nice round circle. Okay? We'll go ahead right here. You see a bunch of different terms, and we will learn about them coming right up. Well, here we go. Let's start with these core concepts. Okay? The first one, lines and segments that intersect circles. A segment whose endpoints are the center and at any point on a circle is a radius. So remember, when you're taking a look at this diagram right here, the radius is from the center to the outer part of the circle. And when it's more than one, we say radii. Okay? This new term that you're going to be looking at right here happens to be that of a chord. And a chord is a segment whose endpoints are on the circle. Okay, so if we take a look this time around on the diagram, a chord, you can see it has endpoints on the circle right there. Okay, now this is kind of important to know. In the next sentence, it says a diameter is a chord that contains the center of a circle. So if we take a look right here at the diagram, and I'm going to go ahead and highlight the diameter, well, we could technically say that the diameter is a chord. But more specifically, because it goes through the center, that's the difference between the diameter and chord. Okay? The diameter goes through the center of the circle. So then let's take a look at our next term, secant. Secant is a line that intersects a circle in 2 points. All right, so we're going to go ahead and take a look at this next diagram right here. And we'll take a look and see right here that a secant, once again, is a line that intersects the circle at 2 points. Okay. Now, just because something is a secant, remember, we do have 2 endpoints right there, right? Or 2 points. When a line and the circle intersects at 2 points. We could also call that the point that's in between that being a chord. All right. Next up, a tangent line. A tangent line is a line right here that only touches the circle at one spot, okay, or at one point. So right here, a tangent is a line in a plane of a circle that intersects exactly at one point. And we call that point right there, it's the point of tangency, as you can see where it is pointed in the drawing, okay, or in the diagram. So that one point is the point of tangency. The tangent ray AB and the tangent segment AB are also called tangents. I included right here in the notes, and you're going to want to include that for yourself as well, is this. 10.1, tangent line to a circle. A tangent line is perpendicular to the radius. Okay, so that right there is a very important concept to understand. That a line or a tangent line, that point will be perpendicular to the radius. So if we go back to this diagram right here, if I go ahead and draw a point from the radius to point B, or sorry, the center to point B, this happens to be perpendicular. Another key piece of information and note right here is the external tangent congruence theorem. And that states that tangent segments from a common external point are congruent. So you see right here I have a diagram. I've got a circle, and what I have are two tangent segments. Okay, so, and I'll go ahead and highlight or draw. We got tangent segment 1, tangent segment 2. Okay, and so what this is saying is that these tangent segments are congruent if they meet at a common endpoint external, or sorry, a common external point, which they do right here. All right, so there you have external tangent congruence theorem. Moving right along, we'll now talk about coplanar circles and common tangents. Okay. In a plane, two circles can intersect in 2 points, 1 point, or no points. Coplanar circles that intersect in 1 point are called tangent circles. All right. Coplanar circles that have a common center are called concentric circles. So once again, coplanar circles that intersect at 1 point are called tangent circles. So you can see right here in the middle, the 1 point of intersection diagram. This right here shows tangent circles because they both share 1 point for each circle. Okay. There happens to be 1 point of intersection right there as well. You can see right here, and all the way to the right-hand side, we have our concentric. This one right here happens to be a concentric circle. Why is that? Because they both, two circles right there, they both share the same center. Okay, so you can see that they both have the same center, makes them concentric. Do any of these circles intersect with each other? They do not. Okay, so they do not have any common tangents. Let's go ahead and come down right here. So a line segment that is tangent to two coplanar circles is called a common tangent. A common internal tangent intersects the segment that joins the center of the two circles. A common external tangent does not intersect the segment that joins the centers of the two circles. Let's take a look at some of our extra practice right here. So we're going to use the diagram to the right to answer the following 6 questions. Now there are more than one answer that you can have right here. Okay, so I'll try to go over as many as possible to try to give you different, show you all the different scenarios. So now number 1 says name the 2 radii. Okay, or name 2 radii. I could definitely show you that there are 3 right here. I see that there's AF, right? Segment AF is a radii. Hopefully next up you see that segment A to D. Right there is a radii. And so is segment AB. There you have it. We've got 3 radii. Remember, it starts from the center, so I want to use that point as the first one, and then going out towards the end point of the circle, or the point at on the circle. Next up, let's name a chord. Okay, so let's have right here a chord. Remember, is a segment on the circle that has 2 endpoints. So I went ahead right there. We can go ahead and put C to E as one chord. And do we actually have another one? Okay, don't forget, we talked about that there could be another one, and that would be D to F. However, D to F I'll kind of give that like, I'll circle it and kind of give it a question mark because remember, D to F, it actually has this more specific name for it because it goes through the center. And because it goes through the center, it leads to our problem number 3. Name the diameter. That would be segment DF. So diameter, there's only one because remember, it has to go through the center. Unlike a chord, it just has 2 endpoints on the circle, a segment with 2 endpoints on the circle. All right. So DF could be a chord, but we really wouldn't call it one. Okay. Let's go ahead and take a look at number 4. Next up, it says name a secant. Okay, so what exactly is a secant? Hopefully we go back and remember that a secant right here is a line that goes through a circle, okay? And it has 2 endpoints. All right, so that right there would be DE. Right, line DE would be a secant, 2 endpoints on that circle. And it goes through it. Next up, number 5, name a tangent. Tangent right here, remember, is a line that touches the circle at one spot. And so the only way for that to happen would be, hey, that segment has to be a line, or the line has to be, something that's tangent has to be a line, right? It can only touch it one time. So we can go ahead and right here put line through point B. 6, name a point of tangency. Remember, that point is going to be where that tangent line intersects with the circle, and that would be point B right here. There's your name, a point of tangency. All right, let's go ahead and move along. Let's take a look at number 7. It says, tell how many common tangents the circles have and draw them. All right, well, how many common tangents do they have? Remember, a tangent line is a line that goes through or touches, sorry, it doesn't go through the circle, but it only touches the circle at one spot. So this line has to touch both circles, right, at one point each. So let's go ahead and figure out how many there are. If I draw a line just like this right here, that would be one common tangent. Right, you see how that line goes through each circle one time at one point, okay? Right here, I could do the same thing at the bottom of the circle. And there you go. How many common tangents do we have? We've got 2. All right. Number 8 says, tell whether each common tangent identified in exercise 7 is internal or external. Well, if I look at those tangents, they're on the outside of the circle. So we can go ahead and say that this is external. Okay, and then remember, external is outside. All right, so there you have right there, number 8. Taking a look next up at number 9. Okay, it says point D is a point of tangency. So that's right there some important information because remember, one of the things we mentioned is that the point of tangency and the radius right here, what's the relationship? Hopefully remember me telling you that it's perpendicular. So guess what you see right here? You see this lovely right triangle. Like I told you, it's not going away. It's right there for you. So if you look at the diagram, we've got A to D, which is 5.5. That's your radius. You have A to B right there, which happens to be 10. And then we have B to D. So what can we do? Right? I'm trying to find B to D. And the only thing I can do is, hey, realize I've got a right triangle. And what can I do with that right triangle? I can use the Pythagorean theorem. All right. So if that is the case right here, let's put it all together, right? I could say AD squared plus DB squared is equal to AB squared, right? So we've got ourselves our Pythagorean theorem. We'll put things in. We've got A to D is 5.5 plus D to B. I'll go ahead and put X for that right now. It makes it a little bit easier for us. And then A to B happens to equal 10. We'll put 10 squared. All right. So let's go ahead. We'll simplify all of this. We got, looks like 30.75. All right, we put 5.5 squared. Oh, sorry, 30.25 plus x squared is equal to 100. All right, let's get x squared by itself. So I'll subtract 30.25 to both sides. And then we got ourselves 69.75. And then finally, we'll square root both sides. And x is equal to approximately 8.4. Right? And there you have it, 8.4 right here. Okay? And that right there would end up being B to D. Next up, we'll take a look at number 10. Point C is also a point of tangency right here. And says if B to C is equal to 4.6, find the value of x to the nearest tenth. All right, so we're going to put together what we just learned, okay, or the answer that we just got. So remember, I guess somebody's mad outside. If you hear that horn, don't know what that is. It might be the train or something. Just disregard that. And so let me go ahead and kind of, here, I'll draw the circle again. And you see that there's a lot of, there's a lot of stuff right here in the original diagram. But what they're saying is that from B to C, okay, that's 4x plus 6. And then we have right here B to D. Well, remember, we just figured out what B to D happens to be, and that is 8.4. Now remember, there's all those extra theorems that I gave you guys in the beginning that you didn't see right here in that I added to the notes. That external tangent congruence theorem. That if two tangent lines happen to be, they meet at an external point, guess what? In this diagram that I'm just put together, C to B and D to B are congruent. Let me go ahead and move that up for you so now you can see it. They're both congruent. So what can I do here? Quite simply, let's take 4x plus 6, and I'll set that equal to 8.4. Just like that. Easy, right? So we'll go ahead, we'll subtract 6 to both sides, and I get myself 2.4. We'll divide both sides by 4, and then you get your answer of 0.6. Okay, and that is x to the nearest 10th. All right, there you go. Starting off chapter 10, we got 10.1. Actually, there's one more problem I want to go over. And let's put that right here in this extra notes section. So actually a very good question. And so this is what you're also going to see too. This one's a little more complex. That's why I need to go over it. Maybe you got this under control. But let's say we go ahead right here. I've got myself a tangent line. Okay. So we have ourselves a line that's tangent down here. And so we got a 90-degree angle. And let's go ahead and say that in the diagram that we have these two parts that are radii, and then we also have right here an external segment that's 18, and then the tangent segment is 24. Okay, so your goal right here is to solve for r. How do I find the radius? Well, what do? Remember, what type of a triangle do we have here? We've got ourselves a right triangle. So what you're going to have to do is go ahead and use the Pythagorean Theorem again. But is it just that easy? This is why it's not that easy, because look, I'll go ahead, we'll set this up. We got r squared plus 24 squared, right? Those are the two legs. And then we have the hypotenuse. And the hypotenuse is going to be r plus 18, and we have to square that right there. So that's what makes this the challenging part to this question. Because what do I do with that r plus 18? All right, you got to make sure you multiply that out. R plus 18 times r plus 18. So if we go ahead and do this, we've got r squared. Okay, that'll stay the same. We got 24 to the second power. And that right there happens to be 576. And then this right here, the tricky part is making sure you realize that, hey, it's not just r squared plus 18 times 18, which is 324. You've got to make sure you FOIL this. And that's the big common mistake that's made. That many students will just put r squared plus 324. Instead of remembering, oh, this right here is r plus 18 times r plus 18, and you're going to have to FOIL this out. That is the common mistake. So let me go ahead. We get r squared plus 18r plus 18r, which is going to be 36r, and then plus 324. Okay, so I once again right here, I just FOILed things together to get that trinomial. And so now, typically, we want to set this equal to 0, okay? Especially when we have a exponent to the second power. But this is what I want to figure out. Hey, if I subtract r squared to both sides, the r squares will cancel. So how about this? Let me go ahead and also subtract both sides by 324. And so we got ourselves 36r is equal to, well, 576 minus 324. We got ourselves 252. And so lastly, or last but not least, we divide both sides by 36, and r is equal to, and we get ourselves a nice number of 7. And you figured out what the radius of the circle is. All right, so there you have it. We now finished 10.1. Go ahead and get to work. If you have any questions, please let me know. If you like what I'm doing, please subscribe, like, and follow. That's what everyone else likes to say. All right, guys, have a good one.